So now let's go on and solve our higher order polynomial equations using this quadratic form or U substitution technique. So there's an example here done out for you that I would encourage you to take a look through. Let's do one together, or maybe a couple. So let's look at example 2. In this case here, we have a higher order polynomial of 4. So we want to write that in quadratic term. With that being said, I'm going to let my u value be x squared, because I know if I raise x squared to the second power, it will give me x to the fourth. So now I can rewrite this as 24 u squared plus 14u minus 3 equals 0. Now I ask myself, can I factor this? So can I actually go ahead and factor it, or would I have to use the quadratic formula? We can factor this. You can either use guess and check, which I encourage you to do, or you can factor it by grouping. So I'll show you the factoring by grouping technique just for some of you who still need that. So we say what multiplies to negative 72 and adds to 14. And that would be positive 18 and negative 4. So I'll have u squared minus 4u plus 18u minus 3. And now we group. Group the first two terms, the second two, factor out a 4u here. We get 6u minus 1. Factor out a positive 3. And we get 6u minus 1. These match, so that's good. And now we have 4u plus 3 times 6u minus 1. And if I continue on with that, we will now set each one to 0 to solve. This would give me u equals negative 3/4. And this one will give me u equals 1/6. Now remember, those are not my answers. The problem did not have a u as the variable, the problem had an x. So we now have to go back and substitute that x squared in for my u. So x squared equals negative 3/4 and x squared equals 1/6. So let's solve each. In this case, we would take the square root of both sides and we would get x equals, remember our plus or minus, got to take out an I root 3 all over 2. In this problem, we'll take our square root. The good news here is that we don't have an imaginary, but we do have to rationalize. So this would be 1 over root 6 will now multiply by root 6 over root 6, and that gives me plus or minus root 6 over 6. So here are really my 4 solutions. Plus or minus I root 3 over 2 and plus or minus root 6 over 6. Let's go look at example 3. In this case here, we don't have a quadratic yet, and it's not quite a higher order, right? It's not a 4 or a 6. In this case, we have a radical. So just like before, whatever's attached to the b value is going to be my u. So we will have that u equals root x. So I will have u squared minus 7u minus 8 equals 0. This is a really quick one to factor, right? What multiplies to negative 8 adds to negative 7, simply u minus 8 and u plus 1. That gives me that u equals 8 and u equals negative 1. But recall, we're not looking for u, we're looking for x. So now I need to substitute back in. Root x equals 8 and root x equals negative 1. So if I solve for x here, what do I do to undo a square root? We have to square both sides. So I have x equals 64. Now over here, we have to be very careful. I'm not going to continue, because can you ever take a square root and get a negative answer? No, The only time you can get a negative answer is if there was a negative out front, which there is not. So this we cannot do. So with that being said, we only have one solution for this problem, and it is that x equals 64. Now on to example 3, and I will let you try this one, but I'll start it off for you. What I notice about this example is that it's a difference of 2 cubes. So if I recall our factoring of cubes, we take the cube root of x to the third, that's x. I take the cube root of negative 27, and that's negative 3. So our factorization is x minus 3 times x squared plus 3x plus 9. Now, once it's factored, we set to 0 and solve. So x minus 3 equals 0, and x squared plus 3x plus 9 equals 0. Well, this is super easy to solve, right? That just gives us, not you, x equals 3. But this one here, we can't keep factoring this, so what I now need to use is the quadratic formula to solve, which I will let you try. Come back to look at the finished answer though. One thing I do want to note is a lot of times people will solve this by adding 27 and taking the cube root. What happens there is that you only get one answer. So it's really important that you factor this, and then you'll end up getting 3 solutions. X equals 3, and then the 2 answers from our quadratic formula. And one way to kind of check that is the power is 3, so I know I could get 3 possible roots. So again, 1, and then the 2 from our quadratic formula make 3.